to try to get not congestion happening in the network. Now, a key point here is that every one of the routers in the whole chain end-to-end has to support this diffserv and look at that information in the header of the IP packet and run these algorithms. If you've just got differentiated services here and there, and then you go across an IP network that doesn't support this, like the carrier's routers never look at those tags, then you don't have class of service end-to-end. So the carrier would have to implement this on a shared IP network as well as you, and then you could get end-to-end class of service guarantees. This all looks very familiar, and in fact it looks almost identical to ATM, but this is the IP people's solution, whereas ATM is the phone company people's solution. In this chapter, we're going to look at deploying voice over IP inside the building. And to benchmark this, we'll look at the traditional ways that we do telephony in building, PBX and Centrex first, and then look at voice over IP afterwards and compare the two. With a PBX, that stands of course for Private Branch Exchange, the idea is that your organization goes into the local telephone business. You get a telephone switch, you can buy, rent, or lease one, and you put it in the telephone room in your building, and then you connect all of the telephones inside the building to this telephone switch, the PBX. At that point, each user could pick up the phone and get a dial tone from the PBX in the telephone room, and they could call from one cubicle to another, maybe just by pressing 4 buttons. If you want to talk to somebody who's not connected to that telephone switch, then you have to connect the PBX to the public telephone network. And the way that that is done is with PBX trunks. A PBX trunk, don't tell anybody, in its simplest implementation is the same thing as a regular telephone line, but we change the name and charge more for them. And each trunk connection would allow a user to pick up their phone, get a dial tone from the PBX, press 9 for an outside line, and get a second dial tone from the central office switch. And for each person that can simultaneously do that, you need a PBX trunk connection. Obviously, we don't have one PBX trunk for every telephone inside the building. We base our calculations on the statistics of how often people pick up the phone and press 9 for an outside line, and a rule of thumb is it's usually around a 10-to-1 ratio. So if you had a building with 200 phones in it, you'd get 20 PBX trunks. Now, if you had 20 PBX trunks, chances are real good that you're not going to have 20 individual copper wire-based PBX trunks coming into your telephone room. They will be carried on a carrier system. And one that has been popular for a long time is T1. T1 is a carrier system that allows us to carry up to 24 channels between one place and another. And in the simplest implementation, what we would do is put a T1 in between the central office switch and the PBX switch, and we could then carry 24 PBX trunks. Now, as far as the user is concerned, in that scenario, they don't know they've got a T1. It's not adding any value to the story. It's just carrying 24 trunks from point A to point B. If we want to pay extra for a value-added service called ISDN PRI, Primary Rate Interface, this is a value-added service that needs to have a physical connection like a T1. What the PRI service does is allows us to use 23 of the channels for doing actual voice or data communications, and then the 24th channel is used for exchanging control messages between the central office switch and the PBX. And examples of control messages would be, stop sending phone calls here, we're busy, send them somewhere else. and a whole list of other control functions. The set of control functions is called ISUP, the ISDN user part. The simplest example of a control message would be that there's a phone call coming in on channel 23 and it's coming from this network address that has this name associated with it, and it's for this extension on the PBX. Lots of other ones are available, going all the way up to sophisticated stuff for doing load balancing for call centers, so that if you have 1-800 number and it is directed to different call centers in different parts of the country depending on where the person's calling from, that we can redirect where those calls are terminated. If we get busy in one call center, then we can send them to another one. As far as advantages and disadvantages go, the main advantage of having a PBX is that you don't have to pay the phone company to do moves and changes. You're providing the telephone service inside your building, so you can hire an employee to do moves and changes rather than having to pay the phone company $80 or $100 every time you need to have a phone line moved from one cubicle to another. Historically, you were able to get more features on a PBX than you were able to from the phone company, but that's not so much true anymore. As far as disadvantages go, well, you're going into the local phone business, so you have to worry about having a physical place to put the PBX, having physical access control for that, security, fire suppression, and powering. The PBX typically powers the phones, and so you have to have a way of powering the PBX. And if you just plug it into the electrical service, then if the electrical service goes down, so does your telephone system. So we want to have an uninterruptible power supply. You have to figure out how long you want your telephone system to work after the electrical system shuts off. 5 minutes? That's 4 Sears die-hard batteries connected together in series, and you plug the positive terminal into the ground and you got minus 48 volts in your hand to power the PBX. If you want it to run for more than 5 minutes, you have to charge up those batteries. In remote areas and small locations, we use propane generators to do that because they're small and easy to handle the fuel. For big installations, we use diesel generators. Now, if you want your diesel generator to keep running for, say, 7 days after the power shuts off, let's say the big quake hits in Silicon Valley and all the power for 25 miles around is on the ground, they ain't going to be coming back anytime soon, you got to have a guaranteed delivery of fuel to run your generators, to charge the batteries, to run the PBX. And guaranteed delivery of fuel, that means that before the disaster happened, you had to sign a contract so that when everybody else wants the fuel, you're the one who gets it. Now, you can do all of this stuff yourself, or you can pay the phone company to do it for you. Paying the phone company to do it for you is called getting Centrex service. And that's a generic term. Every phone company is going to have their own brand name for it. The idea here is that you do not have a telephone switch of your own. You use the phone company's phone switch. And they'll run a little software program on their phone switch called a Centrex partition to make it look like you have your own little telephone switch. In other words, you can punch 4 buttons and a phone in the cubicle next door is going to ring. But all of this is done on the telephone switch in the central office, the same one that's used to provide residential service in that area. The implication here is that we no longer have trunks going between your building and the telephone company. We've got individual lines. Now, if you've got 200 phones in your building, they're not going to run 200 individual lines to your building. They're going to use a loop carrier system to move those from their building to your building. And this could be a T1 if you've only got a few, or it could be a fiber if you've got lots. And this will terminate on a box in the telephone room from which loops come out to go to all the phones. Now, the advantages of this are that you don't have to go into the local phone business. You don't have to get a PBX and maintain it and worry about all of that sort of stuff. It's a lot more scalable because you can buy 2 Centrex lines or you can buy 10,000.